Welcome to a tutorial on advanced IGA mesh generation and applications to structural vibrations, where IGA stands for isogeometric analysis. Quite some people have directly or indirectly contributed to this tutorial. Takashi Kuraishi, Yuta Otoguro, Kenji Takizawa, and Tefontes Duyar from Rice University and Waseda University team, and me, Lisa Vobas, and Yuri Bazilevs from YB Numerics and Brown University team. In this video, I will give a short introduction to IGA mesh generation and show you the basic features of pointwise. In the next video, I will explain how to use pointwise in order to create a simple geometry from scratch. Our main focus will be on mesh generation, but the eigensolver and post-processing will be discussed as well, just to provide a comprehensive picture of the adapted computational process. This scheme presents the main steps within the computational workflow and software corresponding to each step. To be precise, the mesh generation is split into two stages: the generation of a block-structured mesh that is done using pointwise, and the projection of this mesh into a non-uniform rational basis spline mesh using TFSM software. The computation step describes the solution of the eigenvalue problem that is obtained using in-house software and SLAPC, and the final step, so-called post-processing, includes the computation of physical representation that is performed with TFSM software and visualization in ParaView. Although in this tutorial we use pointwise to create a block-structured mesh, it can be replaced by any software package with similar features. Also, the eigenvalue problem is just an example of a computation that can benefit from an IGA mesh. The presented mesh generation approach can be applied to CFD simulations, FSI simulations, and so forth. In short, the workflow is very flexible, and the presented mesh generation technique can easily be applied to a variety of problems. As was indicated on the previous slide, in the first stage of our mesh generation approach, we build a block-structured mesh. Such mesh divides computational domain into subdomains. Each subdomain is meshed separately and is joined with its neighbors. Pointwise is commercial mesh generation software. It can create a mesh from scratch or build it from a database. Here on this slide, on the left-hand side, we see a mesh that was generated from scratch. It's a frustum that consists of 5 blocks. And on the right-hand side, we see a mesh that was built upon a CAD database. This is a nuclear reactor pressure vessel that consists of 568 blocks. Let's take a look at the pointwise interface. On top, we have the menu bar. It provides access to some of the most essential commands in pointwise. So, for example, we can create a new project or open an existing one. We can also save our progress and import or export data. That can be done through grids and CAD databases. The menu bar also contains tools for geometry and grid generation, and it provides information about the grid. Right now the project is empty, so all these features are not available, but this will change once a grid is created. Under Edit, there is a variety of editing tools. The most commonly used ones are also accessible through keyboard shortcuts and the horizontal toolbar. There are two toolbars in pointwise, the horizontal one and the vertical one. The horizontal toolbar allows to change the appearance of the geometry, create grids, and controls the ability to select different components of the geometry. And I think the easiest way to explain its functionality is by creating a small example. I'm going to make use of one of the predefined shapes and create a cuboid. Since the geometry generation will be explained in a different video, I'm going to keep the default settings and hit Apply and OK. So now we can change the transparency of the geometry, and we can adjust its color. We can also work with just one of the surfaces. So let's make it red. Right now I have to be careful not to select other grid elements when I'm working with the surfaces. Although for this example, it's not very problematic, it can become a major issue for larger geometries. So to avoid this, Pointwise provides the masking tool where I can deselect volumes and lines, and this will allow me to work exclusively with the surfaces. Pointwise also has several options for view manipulation. For example, you can hold Ctrl and use the right mouse button to rotate the geometry, or you can use Shift and the right mouse button to translate it. There's also a view manipulator in the display window, and there are certain predefined views in the vertical toolbar. In addition, the vertical toolbar allows to hide certain elements of the geometry, and it provides tools to manipulate the geometry. At the bottom, we have the message window. It's optional, but it's very useful. It contains the history of the commands and the error messages. And then there is the status bar. It gives the information on the current stage of an operation and the main features of the project. So in our case, we can see that we are working with a structured grid in 3D environment. And then on the left-hand side, we have the panels. One of the panels is used to create layers within the project. I will talk about layers in more detail in another video. And then there are the default values and the list of entities. To be able to explain this list, I have to introduce some of the Pointwise terminology. So first of all, an entity is an individual grid or database element, and a database is a CAD geometry that is imported from other sources or created directly within Pointwise. Then there are connectors. In our case, we have 12. A connector is a 1D grid element which forms the foundation for all the other grid hierarchy. A domain is a 2D grid element which can be structured or unstructured, and we have 6 surfaces, so we have 6 domains. A block is a 3D grid element which can be structured, unstructured, or hybrid, and in our case we obviously have only one block. And then there are sources. A source is a 1D, 2D, or 3D entity which is independent of the grid and database. It is used to locally define target edge length for connectors, domains, and blocks. And there is also spacing constraints. A spacing constraint is basically user-defined grid point spacing adjacent to connector nodes. You can find more information about Pointwise on its website, and this concludes our short introduction to the Pointwise interface.